To analyze the recording from the second site, I'm going to click on 2.1 pair button. The signals are loaded, and as before we can see the signals that were acquired shown in the top window. I will maximize this. What is a good position for placing the window? That's a question that I often get asked. You always want to trigger at a location where you got minimal activity from background signals, but that's not necessarily the best location for jitter analysis. It should be on the sharp portion, and I usually like to place it near the baseline or halfway between the peaks. So this is where I would position it. What should be the duration of the window? Does it make any difference? No, it really doesn't make any difference if I make it short or if I make it wide. The system will measure the time from the first crossing in this window. Let's look at the second window. This is the default position that was set automatically by the program. Now, where is the time measured? We can see the potential crossing going on the downward edge. It is also crossing on the upward edge. In the bottom left corner, you will notice that we are using the rising edge and the level trigger. So although the signals are crossing this window, because it's on a falling edge, that's not used for assessing the interpotential interval. It is using the rising edge. But if you feel more comfortable, you can change the position of the window. You can bring it like this. Once again, notice that I'm putting it roughly between the peaks. This is where the signal is at its sharpest. It's not necessary, but if you feel compulsive, you can also adjust the duration. So right now I'm analyzing the time interval between the first potential and the second potential. Let's look at the interpotential interval distribution. Once again, we have a very nice plot over here. Let's look at the jitter value. In this case, we had 131 discharges. Let me maximize the window. So we had 131 discharges and the jitter was 17 microsecond. Once again, MCD was less than MST. So this is a very normal jitter recordings. I do not see any artifacts. There is no further need to edit these traces. We also have another potential in this recording over here. So how can we measure the jitter? Well, the first step is to declare that I have a new pair. So I will do so by clicking on the F1 function key. Notice in my result table, I have a new entry over here which says 2.2 pair. And now I can reposition the windows. Here are some signals which got re-triggered when I changed my trigger level. So I'm going to bring it up like this. And I'm going to position the second window over here. Let's look at our interpotential interval distribution. We have a nice distribution, once again close to 150 data points. 2 of them are outliers. And that's actually a great way of knowing that we have a good quality signal. When you get about 1% rejections based on a 3 standard deviation, I personally think that's a very good quality recording. So I'm not concerned that 2 sweeps were actually thrown out of analysis. Now come back to our normal recording. You will also see there are some traces in blue color over here. These are the traces that did not cross the window, the start window or the stop window, and therefore they were excluded from analysis. So blue color means these are the traces not used in jitter analysis. When we look into our interpotential interval graph, we can see those traces at the top. They did not cross either of the windows. For my second pair, I have got 96 discharges over here, and my jitter value is 18 microseconds. Both of these are very good values. It's also possible to measure the jitter between the second and the third one. Let's do this. I'm again going to click on New Pair. I'm going to move my second window on this potential. Again, you don't have to maximize these windows to position them. So now I'm measuring jitter between the second and the third potential. Let's look at the interpotential intervals. Very nice distribution. And the jitter over here is 23 microseconds. Now, the rule is if you have a triplet, you can measure only 2 jitter values. If you have a quadruple, you can measure only 3 jitter values, and so forth. In this case, we have made 3 different jitter measurements, but we can analyze or accept only 2 of those. I usually discard the largest value. So 2.3, that had the highest jitter value. So I'm going to delete this pair from analysis. So now I'm left with only 2 analyses from site number 2. So we have completed analysis from the second recording.